Hello, good night. Today at the time I'm recording this, it's 7:30 p.m. and today I will be doing a problem solving of week 2 problems, an explanation video of the problem solving. This is task from Dr. Putu Gunawan on week 2. And my name is Nyoman Manutama Surya Jagadhita, and today I will be doing the explanation video. Let's go with number 1 first, or specifically number 1.3. So in the problem we got integral of square root of 1 plus square root of x over x dx. So the first thing we need to do is to substitute x or square root of x with u to simplify this problem. So let square root of x become u, and then x can become u squared. And then for the dx we can derivative or take the derivative of this square root of x equal to u become 1 over 2 square root of x dx and equal to du. So and then we simply make this times both of this 2 square root of x, so this becomes this cancel, and then 2 of square root of x become here, or dx is equal to 2 square root of x du. Can substitute dx with this square root of x with u and x with u square, and it's become like this: integral of square root of 1 plus u over u squared times 2 times u times du. Can simplify them again, get 2 offset of the integral, become this one: 2 times integral square root 1 plus u over u du. After that we need to substitute again. So let phi become square root of 1 plus u, this one, and then u become phi squared minus 1. Substitute those to here, this one 2b, this one become phi, and then phi squared minus 1. Also du, we need to take a derivative of this one, become this one: 2 square root of 1 plus u du dv equal to du. So we can substitute, we need to simplify first. So this one become phi too, this one, because phi is this one, so it's become 2 phi du, 2 phi dv, and is equal to du. We can substitute this to here, so it's become 2 integral of phi times 2 phi dv. Same, we can take 2 out, get 2 out of the integral, become 4 times integral of phi squared over phi squared minus 1, and then this form can become this one. After that we can give each one its integral. It become integral 1 dv minus, because of minus, integral 1 over, we can expand this to p plus 1 times p minus 1, so we can do the partial. For the partial, it is not simple, but we can deal with that. So the form become like this: a over v plus 1 plus b over v minus 1, and then add both like this, and then we found it. We get this one, and then we got this one. We need to get like that, and then this one is a form of 1. We can get the value of this and this from this. So a plus b is 1 because a plus b is 0 because there is only 1 here, no b, and a minus b is a constant, this constant, so it become 1. Then just do the equation is plus, so plus a minus b is going to cancel. It's become a plus a, 2a is equal to 1. Then a is 1 over 2. A minus b, a plus b is equal to 0, is equal to 0, so it's become a equal to minus b. So minus b is 1 over 2, so b is minus 1 over 2. So just substitute this to here and this to here. We got this, substitute this to here. Okay, so we got a nice easy to integral form. And then this we already integral v, it's become 1, integral of 1 dv is become v, the constant rule, minus this become this. We take out 1 over 2 outside, and then 1 over v plus 1 integral is ln natural log of v plus 1, and also is v minus 1 is also the same, ln v minus 1, so it's become 1 over 2. Also get out the integral, become v minus 1 over 2 ln v plus 1 plus 1 over 2 ln v minus 1, and then just times 4 to each of them, become 4v to ln 2 because 4 times half, so it's 2 ln v plus 1 plus 2 ln v minus 1. And then the value of v we have earlier is this one, so we substitute this here, become like this. Also the u we have is square root of x, so it's become square root of 1 plus square root of x, so it's become like this. Substitute this to v, yeah, like that, this with v. So that's for number 1. Next, for number 2, this is take 3, I guess. So we got a problem here, integral of 1 over t square times square root of t square minus 16. So in this trigonometric substitution problem, we can use this table to help us solve this one. So first we look at this one to know what integral is involving. So this one, so we know the t value, or the not the constant, this one t is a second, so it's using second. So we do it, so we do the substitution, will become this one in second. It's using second, so if it's using second, we can just look at this second, so it's c over b, or hypotenuse over the side, so it's t over 4 equal to second. So t over 4 equal to second, so just times both of this with 4, so we got t equal to 4 second theta. The same with this one. we got the rights, or just take the derivative and become dt equal to 4 second theta tan theta d theta. And then for tan theta we get tan we get a over b, the opposite over the side, so this over this become like this, and then we want this value, so it's come here, or times 4 and then times 4 this, so this cancel, this become 4 tan theta. And then we got all of those value, we can substitute all of them here. So d theta become 4 secant theta tan theta, and then d theta. D square become square of this one squared, and then this one become 4 tan theta. So we can do a bit of simplification. This cancel, tan theta cancel, so we left with 4 secant theta times 4, so it 1 over 16 secant theta, integral respect to the d theta. So 1 over 16 can go out from the integral because of constant, so 1 over 16 times integral of cos theta d theta, so cos theta, integral of cos theta is sin theta, so it's become sin theta a over c, so yeah, this over this, so 116 times sin theta, we can substitute this one, it's, wait a minute, a over c, opposite over the hypotenuse, so it's become 1 over 16 times square of t square minus 16 over t, so it's become square of t square minus 16 over 16 times t plus the constant for the integral. That's done. Quite simple, but need to remember the rules. Alright, number 2 done. The last number is 3 in the method of partial fraction, so we're going to do some partial now. Actually it's for number 3.2. So the problem is integral from 1 to 2 of 15 over x squared plus 7x plus 12. So first thing first, we can get off the constant, so 15 can get off of those, so become 15 times integral of 1 to 2 of 1 over, we can expand this form, become this, so we can do the partial. So this one can become this x plus 3 times x plus 4 dx. So this form we can make it into look like this: a plus x plus 3, this one, plus x plus 4. Just do the usual fraction addition. We actually don't need this bottom value, we need this, the upper one. So it's become x a times x plus 4 plus b x plus 3. We do the multiplication: ax plus 4a plus bx plus b3, and then takes the same the x value and the constant. It's become like this because all of this is plus, so we can do plus here, so a plus b, because ax plus bx, we can take out the x, so a plus b times x plus for a plus 3b or b3, and then we know this value is 1 because of this one. The constant is 1, but we don't have x here, so it's 0 times x. So 0 plus 1, it's 1. So it's uh, you know complete the requirement, I guess. And then we can do the finding the value of a and b. So a plus b is 0, 0. So we can say that a minus b, a is equal to minus b. So if a value is positive, so the b value will be negative. And then for a plus 3b is equal to 1. Next is for the 4 minus b plus 3b is equal to 1. So we substitute this with this. So 4 minus b plus 3b is minus b equal to 1. So b times minus, so b is equal to minus 1. If minus b is a, so b is minus a. So if b is minus 1, then we can times minus 1 for a to get the value of a. So a is 1. We substitute this to b. This b it's become minus 1 because we got this. This become minus 1. This become minus 1. And then a become plus 1. So this plus 1. Plus 1 minus 1. So it's become 15 times integral from 1 to 2 of 1 over x plus 3 minus 1 over x plus 4 dx. We can use this one is ln 1 over x is ln x, so this one, if we let this be x, so it's ln x. X is x plus 3, so it become 15, still in the integral 1 to 2, 15 times ln of x plus 3 minus ln this is minus ln x plus 4. After we got this value, we need to calculate the boundaries. So first substitute 2. So ln 2 plus 3 is 5, ln 5 minus ln 2 plus 4 is ln 6, and then we minus with 1, the boundaries of 1. So substitute 1. So ln 1 plus 3 is minus, so minus ln 4, and then minus ln x minus ln x plus 4. So x is 1, so it's minus ln 5, but we got minus here, so it's minus ln 4, and then minus ln 5, so it's plus ln 5. Then we can calculate this. After we got this value, we can simplify again. So ln minus ln can be used as if it's ln, minus is divides it's the minus divides it, but the plus we can use times, or we can say if ln 5 minus ln 6 is become a fraction of ln 5 over 6, like that. So it's minus ln 5, so we can, so ln 5 is plus, so 5, ln 6 is minus, so over divide 6, and then ln 4 is also minus, so like it's 1 over 6 times 1 over 4, so it's 1 over 6 times 4, and then ln 5 is positive, so it's times 5. So we simplify this. Ln 15 times ln 5 times 5 over 6 times 4. So we have this value, or it's approximately approach this value. And that's all the question. I hope it's easy to understand. I hope I don't make silly mistakes, or if I do, please forgive me. Lastly, thank you for watching.